This Komatsu excavator hasn't moved under its own power in years. Buried in brush and seized by the elements, it is a monument to neglect. Today, one technician begins the long process of pulling it back from the scrap heap. Heavy equipment, left sitting on damp soil, suffers from accelerated galvanic corrosion. Moisture wicks up into the undercarriage, fusing track links and freezing pivot points into solid iron blocks. Extraction is the first brutal test. A crane hoists the dead weight, placing massive strain on tracks that haven't flexed in seasons. The sheer mass of the caked mud adds hundreds of pounds to the lift. Every hydraulic cylinder on this chassis is likely compromised, their internal seals dried and cracked from prolonged disuse. Getting it onto the flatbed is only a change of scenery. The real work will be unearthing the machine beneath the rot. As the machine settles onto the steel deck, the true scale of the deterioration comes into focus. Earth and organic matter hold moisture against the metal indefinitely, creating a perfect environment for structural rot. Transporting dead equipment requires careful rigging since standard lifting points are often compromised or hidden entirely beneath the overgrowth. He guides the dangling undercarriage down, ensuring the load is perfectly distributed across the truck bed. If a seized track suddenly gives way during transit, the weight shift could be catastrophic. The immediate goal isn't repair, but triage. He needs to strip away the environmental armor just to assess what can be salvaged. Every exposed hose and wire is a total loss, hardened by ultraviolet exposure and degraded by time. The chassis itself, however, was built to withstand intense industrial stress. If the core steel remains solid, the machine can be revived. Back at the workshop, the first mechanical teardown begins. Decades of compressed soil have essentially turned to concrete around the fasteners. Standard hand tools are useless against this level of stasis. He relies on raw leverage, using a long steel rod to multiply his physical force against the stubborn components. Breaking the initial bond is always the hardest part of a deep restoration. Once the crust cracks, the hardware beneath finally yields. But raw force has its limits. Around the engine bay, the approach shifts to tactile precision. The heavy mud hides brittle plastic connectors and delicate hydraulic lines that could easily snap under a pry bar. He uses his hands and a simple screwdriver to carefully chip away the obstruction. Blind prying here risks tearing open vital systems before they can even be evaluated. With the fuel tank removed, the pathway is clear to extract the heart of the machine. The technician methodically disconnects the peripheral systems holding the engine captive. High-pressure hydraulic pumps and fuel lines are unbolted first, isolating the block from the chassis. These fasteners have endured extreme thermal cycling during the engine's working life, expanding and contracting until they lock tight. An impact driver delivers high-torque rotational strikes, breaking the friction that a hand wrench cannot overcome. Once the mounts are severed, heavy-duty straps are rigged directly to the block. The internal cast iron represents the densest concentration of weight on the entire excavator. Hoisting it out completely exposes the lower frame, giving the mechanic unhindered access to the darkest corners of the engine bay. The motor will require its own dedicated overhaul on the bench. For now, removing it safely is a major milestone in the teardown phase. Attention turns to the heavy articulation points on the digging boom. The hydraulic arm operates under immense pressure, converting fluid dynamics into raw mechanical lifting power. Every fitting on these lines must be disconnected with a heavy wrench to relieve residual pressure and free the steel structure. These threaded connections rely on precision flares to maintain a seal. Even minor damage during removal means a costly replacement. As the lines are cleared, he uses a pry bar to relieve the binding tension on the main structural pins. When thousands of pounds of steel sit slightly out of alignment, the connecting joints lock up solid. By shifting the geometry just a fraction of an inch, the pivot pin can be safely extracted. This meticulous separation of components is the only way to inspect the internal wear on the bushings. If a pin has been grinding against dry steel for years, it leaves deep scores that compromise the entire lifting mechanism. deep within the undercarriage lies the central suppressor swivel joint, the critical mechanism that allows the upper cab to rotate continuously while the tracks remain stationary. Accessing it requires navigating a tight, dark space flooded with decades of contaminated grease. The lubricant here has long since broken down, capturing dirt and metal shavings to form an abrasive paste. He uses a long extension bar to reach the recessed bolts, maximizing his torque from an awkward position on the ground. Breaking these deep-set fasteners free requires immense physical effort. The dark sludge coats everything, hiding bolt heads and making tools dangerously slick. Stripping the upper body away leaves only the track frame, isolating the heavy rotation gear for its eventual extraction. This rotary manifold is the bridge between the control valves above and the drive motors below. It is arguably the most complex fluid routing system on the machine. The central swing bearing is a massive, precision-machined ring that carries the entire weight of the upper excavator. Its current state is a testament to severe neglect. The thick coating of hardened grease acts as an insulator, concealing the true condition of the internal ball bearings. He stabilizes the heavy iron frame with wooden blocks to prevent a catastrophic shift during removal. Using an impact driver, he backs out the high-strength retaining bolts that anchor the ring to the chassis base. Lifting this component free is an awkward, heavy maneuver. The sheer mass of the steel ring, combined with the suction of the old grease, fights the extraction. This bearing assembly alone dictates whether the machine will ever operate smoothly again. A damaged swing ring means the excavator will jerk and shudder during operation, placing dangerous stress on the boom. Removing it completely allows for the deep chemical cleaning required to inspect the gear teeth. It is a filthy, unforgiving stage of the teardown. Some parts of the machine are simply too far gone to save. The track links have fused together through years of rust and static tension, turning a flexible steel belt into a rigid, immovable loop. When mechanical leverage fails, the only remaining option is thermal destruction. He fires up an oxy-acetylene cutting torch, applying a concentrated flame that exceeds 5,000 degrees Fahrenheit. The intense heat rapidly oxidizes the steel, blowing molten slag away from the cut line. Slicing through heavy industrial track requires steady hands and patience, letting the heat penetrate the thick metal. As the link finally severs, the sudden release of tension causes the heavy track to drop. He uses a long pry bar to force the glowing metal apart, breaking the rust bond on the idler wheels. Peeling the dead track away from the undercarriage is like shedding the machine's hardened skin. This aggressive removal clears the way for the intricate restoration work ahead. The sheer violence of the cutting torch stands in stark contrast to the precision assembly that will follow. Every severed link represents a complete failure of maintenance, a reminder of the element's power over raw steel. The heat alters the molecular structure of the surrounding metal, but these tracks are destined for the scrap pile anyway. New, flexible rubber tracks will eventually take their place. But first, the skeleton must be laid bare. With the drive sprockets heated and removed, the teardown phase ends and the purge begins. A high-pressure water stream acts as a liquid chisel, blasting away layers of petrified earth and oily sludge. The sheer force of the water forces dirt out of complex hydraulic manifolds and deeply recessed bolt holes. It is a highly satisfying transformation. The water peels back the grime to reveal the original factory green paint, a brief glimpse of the machine's former life. Cleaning isn't just aesthetic, it's a diagnostic necessity. You cannot inspect for hairline cracks in the steel when the frame is wearing a thick coat of mud. Water only removes the loose debris. To prepare the steel for a new life, the oxidized surface must be violently stripped away. An angle grinder throws a shower of sparks as it bites into the frame, removing deep-seated rust and flaking paint. The spinning abrasive wheel levels the metal, creating a scored, textured surface. Primer and fresh paint cannot bond chemically to a contaminated substrate. Every joint and weld must be taken down to bare, shining steel to ensure the new coating will actually protect the machine. A fresh coat of green paint seals the chassis, allowing the focus to shift to the engine block. The overhaul begins with the heavy peripheral components. The main hydraulic pump, driven directly by the engine's rotation, is carefully unbolted and wrestled away from the block. With the pump cleared, the massive flywheel housing is exposed. The flywheel is essentially a heavy energy reservoir. It stores rotational momentum, smoothing out the violent pulses of the diesel combustion cycle to provide a steady output of power. Removing the starter motor provides access to the intricate ring gear that linos the flywheel's outer edge. The technician uses a heavy hex key to break the tension on the main central bolts. These fasteners are torqued to immense specifications at the factory, designed to withstand thousands of hours of high RPM vibration. Loosening them requires significant leverage and patience. Stripping these external blocks away is the first step in diagnosing the internal health of the motor. The heavier the component, the more critical its balance. The flywheel must be handled with care. A dropped and chipped gear tooth would render the entire starting system useless. It is heavy, unforgiving work on the shop floor. The external teardown continues on the highly soiled side of the block. Diesel engines rely on incredibly precise fuel delivery to function. The technician unthreads the high-pressure fuel lines connecting the injection pump to the cylinders. The pump itself is a masterpiece of mechanical timing, distributing fuel at exactly the right millisecond under thousands of pounds of pressure. Pulling it away from the block is a delicate operation, despite the thick layer of oily sludge coating everything. Dirt is the absolute enemy of a diesel fuel system. Even a microscopic particle entering these exposed ports could score an injector and ruin the engine's performance. He sets the complex assembly aside for a dedicated bench rebuild. Finally, the old oil filter is spun off, revealing the dark, contaminated fluid that has been sitting stagnant in the block's lower galleries for years. To access the combustion chambers, the heavy cast iron cylinder head must be separated from the main block. An impact driver strips the remaining bolts from the intake manifold, freeing up the side profile. The technician pries the manifold away, breaking the brittle, hardened gaskets that once maintained the vacuum seal. The head itself is seated against a high-temperature metal gasket, bonded by years of extreme heat and carbon buildup. He uses a hammer to send sharp shock waves through the casting, fracturing the seal without warping the machined surface. A pry bar would risk gouging the delicate mating faces, which must remain perfectly flat to hold compression. Lifting the head reveals the intricate valve train assembly. The springs and rocker arms are suffocating under a thick blanket of black, coagulated oil, proof of infrequent maintenance and severe thermal breakdown in its previous life. The heart of the engine is now fully exposed to the open air. The top end is clear, but the lower rotating assembly remains hidden. The technician attacks the perimeter bolts on the oil pan flange. This stamped steel basin acts as the reservoir for the engine's entire lubrication system. The impact driver makes quick work of the rusted hardware. The sealant holding the pan to the block has cured into a rigid, stubborn adhesive. Dropping the pan finally exposes the heavy crankshaft and the connecting rods. The amount of thick, tar-like sludge gathered in the bottom of this pan is a clear indicator of the engine's traumatic history. Oil should flow freely. This consistency means the engine was starving for lubrication during its final hours of operation. It is a grim discovery, confirming that a total teardown is the only way to save the motor. Every internal bearing will need to be replaced. The crankshaft is the heavy, rotating spine of the engine, converting the vertical violence of the pistons into smooth, rotational torque. Removing it from the block requires absolute precision. The technician loosens the large timing gear at the front, carefully tapping it free with a hammer and a drift punch to avoid damaging the delicate, hardened teeth. The bearing caps are unbolted, releasing the steel shaft from its iron cradle. The black oil residue makes every component dangerously slippery and hides critical alignment marks. He lifts the heavy crank away, revealing the deeply scored bearing journals. The lack of clean oil allowed raw metal-to-metal contact, carving deep grooves into the hardened steel surface. This extensive damage explains why the engine was abandoned. The block is now an empty, filthy shell, ready to be sent off for industrial machining. The teardown is complete. Now, the slow, methodical process of resurrection can begin on the workbench. While the engine block awaits machining, attention turns to the complex fuel injection pump. This is the precision heart of the diesel system, and it is currently buried under a thick crust of grime. The technician moves to a clean workbench to break the pump down into its smallest components. Inside this housing, highly calibrated springs and plungers operate with tolerances measured in 10,000ths of an inch. He uses specialized tools to extract the tiny delivery valves and metering components. Every piece must be meticulously cleaned and inspected for wear. The smallest amount of scoring on a plunger means the pump cannot build the extreme pressures required to atomize diesel fuel inside the cylinders. It is a puzzle of springs, shims, and gears that requires a deep understanding of fluid dynamics to reassemble correctly. Restoring this unit is less about brute force and more about watchmaker-level precision. After the meticulous rebuild, the pump must be calibrated on a specialized test bench. This machine simulates the exact rotational speeds of the engine, allowing the technician to monitor fuel delivery in real time. He connects the high-pressure steel lines and a heavy intake hose, sealing the system for the trial. Absolute cleanliness is mandatory here. A single wipe with a shop towel ensures no stray debris enters the calibration ports. As the test bench spins the pump, the technician carefully adjusts the internal fuel delivery settings. He uses a screwdriver to fine-tune the internal spring tension, modifying how much fuel is injected at specific RPMs. This is the most critical tuning phase of the entire restoration. If the timing is advanced even slightly, the engine will suffer from severe knocking and excessive cylinder pressures. If it is retarded, the excavator will lack the power needed to dig. He relies on the pressure gauges and the physical feedback of the linkages, ensuring the internal governors respond smoothly to throttle changes. The precise alignment of these tiny metal levers dictates the power, efficiency, and reliability of the massive machine. It is a perfect marriage of heavy industrial equipment and delicate calibrated fluid control. Only when the fuel delivery is perfectly balanced across all output ports is the pump certified ready for the engine block. The test bench essentially runs the pump through a simulated lifetime of work in a matter of minutes. The technician checks for microscopic leaks at the high-pressure unions, where diesel fuel can easily escape if the mating surfaces aren't flawlessly lapped. The tension on the governor spring is set to exact factory specifications, preventing the engine from over-revving and tearing itself apart under a heavy load. Back in the machine shop, the heavy cast iron cylinder head undergoes structural restoration. Decades of extreme heat cycles inevitably cause the metal casting to warp, destroying the perfectly flat surface required to seal the combustion chambers. The technician hoists the head onto the heavy steel bed of a large industrial milling machine. He secures it with thick metal clamps, ensuring the casting is perfectly level and completely immobilized. A heavy support bar is locked over the top to eliminate high-frequency chatter during the cutting process. As the massive cutting head begins to rotate, it passes over the iron surface, shearing away microscopic layers of metal. This process restores the true flatness of the head, creating a pristine mating surface for the new head gasket. Without this machining step, the rebuilt engine would immediately suffer from blown gaskets and loss of compression. It is a loud, aggressive process that yields incredibly precise results. After the engine block cylinders were bored out to remove the deep scoring, fresh steel sleeves must be installed. These sleeves act as the new, flawless walls for the pistons to travel against. The block is positioned under a vertical press, and the polished steel liner is forced down into the cast iron bore. It is an interference fit, meaning the sleeve is fractionally larger than the hole it enters. The immense pressure of the machine smoothly drives the metal cylinder downward until it sits completely flush with the top deck of the block. This technique saves the original casting while providing a brand new wearing surface for the combustion cycle. The contrast between the bright, polished internal sleeve and the dark, heavy iron block highlights the depth of the overhaul. Surrounding the press, the workshop is a chaotic mix of discarded parts and fresh oil, the raw environment where heavy machinery is given a second life. The block is fundamentally renewed from the inside out. The final machining step guarantees a perfect seal. The sleeved engine block is placed on a large surface grinder. The machine's abrasive wheel makes a highly precise pass over the top deck, removing a whisper-thin layer of iron and steel simultaneously. This operation ensures that the new cylinder sleeves and the cast iron block are perfectly coplanar. The resulting surface is smooth, bright, and dimensionally flawless. It is the perfect foundation for the rebuilt engine. Any microscopic high spots left from the pressing process are completely leveled away. With the block freshly painted and fully machined, the delicate reassembly begins. The technician pours clean, viscous assembly lube directly onto the new main bearing shells. This thick oil provides a critical cushion of lubrication for the engine's first few seconds of life, preventing dry metal-on-metal friction before the oil pump can build pressure. The heavy crankshaft is carefully lowered into the green iron cradle. It must seat perfectly flat. Any binding here indicates a fatal flaw in the machining. On the workbench, he organizes the heavy main bearing caps, ensuring they are installed in their exact original order and orientation. These caps lock the spinning crankshaft to the block, enduring the violent downward force of every combustion stroke. Their precise torque sequence will dictate the longevity of the entire rebuild. The green paint signifies a fresh start, a stark contrast to the black sludge that previously defined this machine. The heart of the excavator is finally coming together. The internal buildup continues as the rotating assembly is locked down. Using a precision torque wrench, the technician tightens the main bolts, stretching the fasteners to their exact yield point to ensure the bearing caps will never vibrate loose. He inserts a small alignment pin, a tiny but crucial component that indexes the timing gears to maintain the engine's internal rhythm. Rotating the crankshaft by hand confirms that the heavy steel spine spins freely without any tight spots or resistance. Next, the long, multi-lobed camshaft is carefully threaded into the heart of the block. This shaft acts as the mechanical brain of the engine, mechanically timing the opening and closing of the valves. Finally, the critical oil pump is aligned and secured flush against the bright green casting. This black metal housing will act as the life system for the motor, drawing fluid from the pan and forcing it through the tight clearances of the new bearings. Its proper installation is the difference between a smooth running machine and immediate catastrophic failure. The mechanical timing sequence relies on heavily machined gears. The technician mounts a toothed circular gear onto the front shaft of the fuel injection pump. This gear connects the fuel delivery system directly to the rotational timing of the main camshaft. He presses the component firmly onto the tapered shaft, ensuring a tight interference fit. A central locking bolt is threaded in and torqued down, securing the heavy gear permanently. If this connection slips by even a fraction of a degree, the diesel injection timing will be hopelessly lost. To seal and protect the delicate timing gears, a heavy cast cover is prepared for installation. The striking lime green paint of the cover sharply contrasts with the deep forest green of the main engine block, creating a distinct visual identity for the restored motor. He uses a soft-faced hammer to gently tap the complex casting into position, avoiding any damage to the fresh paint or the delicate front crankshaft seal. The circular opening must perfectly concentric with the crankshaft snout to prevent oil leaks. Once seated flush against the block, a power drill speeds up the fastening process. The drill drives the perimeter bolts home, clamping the cover tightly against the gasket and permanently sealing the timing assembly from dust and debris. It is a vibrant, protective shield for the engine's most critical moving parts. The focus moves to the bottom of the block to finalize the lubrication system. The technician bolts the curved oil pickup tube into the internal galleries. Its circular mesh filter rests exactly at the lowest point of the eventual oil pan, designed to draw up clean fluid while blocking any large metal debris from entering the high-pressure pump. A perfect seal here is critical. If the pump pulls air instead of thick oil, the engine will rapidly destroy its own bearings. The tube is a simple, vital straw that feeds the entire motor. At the rear of the block, the foundation for the heavy transmission and clutch is laid down. A large, circular lime green engine plate is aligned on the back of the casting. This heavy metal shield acts as a structural adapter and a barrier against dirt entering the bell housing. He uses the power drill to run the mounting bolts in quickly, pulling the plate flush against the machined rear face. Next, a critical seal housing is carefully positioned over the rear of the spinning crankshaft. This circular retainer holds the main rear seal, the only component preventing gallons of pressurized engine oil from leaking out into the dry clutch assembly. Using a hand wrench, he tightens the bolts in a star pattern, ensuring the seal housing compresses evenly without warping the fragile rubber lip. It is a precision fit on the heaviest end of the block. The heavy electrical and structural components are now mated to the block. The powerful starter motor is bolted to the side, its heavy internal solenoid and drive gear precisely aligned with the space where the flywheel will sit. When energized, this motor will draw massive amperage to physically force the diesel engine to turn over and build compression. Following the starter, the massive clutch housing is prepared for installation. This heavy circular casting bolts directly to the rear plate, creating the robust structural bell that connects the engine's power to the excavator's hydraulic pumps. Handling this heavy cast iron requires strength and careful balance to avoid damaging the delicate rear seal. The engine is rapidly transitioning from a bare block into a complete, self-contained power plant. A fresh, white oil filter is hand-threaded onto the block's side port. Hand tightening ensures the rubber O-ring compresses correctly without twisting or tearing, which a wrench would easily cause. Above it, the heavy cast iron intake manifold is aligned onto the cylinder head studs. Painted a stark black, the manifold funnels massive amounts of filtered air directly into the combustion chambers. Its dark finish contrasts sharply with the vibrant green paint of the valve cover, highlighting the brand new Komatsu model plate riveted to the top. The engine's external architecture is nearly complete, transforming the workspace with its sheer mechanical presence. With the major hardware mounted, the delicate plumbing begins. The technician carefully threads the high-pressure steel fuel lines from the injection pump up to the individual injectors. These metal lines must be routed perfectly to prevent vibration fatigue, ensuring continuous extreme pressure fuel delivery to the cylinders. A single kink or loose fitting here would cause a massive drop in power. The final accessories bring the engine assembly to a close. A clean, cylindrical fuel filter is inserted into its transparent housing, providing a clear visual check for water or debris in the diesel supply. Next, the black alternator is mounted to the front brackets. This small generator is driven by the engine, converting mechanical rotation into electrical current to charge the battery and run the control systems. The technician wrenches the mounting bolts tight before slipping the bright yellow cooling fan onto the water pump pulley. This high-pitch plastic fan pulls massive volumes of air through the radiator to shed the immense heat of combustion. Looping the thick rubber drive belt around the pulleys connects the accessories to the crankshaft. With the tension set, the fully rebuilt, freshly painted Komatsu engine is ready to roar back to life. While the engine is finished, the hydraulic nervous system of the excavator requires a total overhaul. The old, brittle rubber lines are discarded. Using a heavy industrial crimping machine, the technician compresses massive metal fittings onto the ends of thick, wire-reinforced hydraulic hoses. The blue hydraulic press exerts tons of force, permanently locking the steel collar onto the rubber. This specialized crimp must withstand thousands of pounds of fluid pressure without leaking or blowing completely off under load. It is the only way to guarantee the machine's lifting power remains safe and predictable. Replacement parts for a machine this old are rarely found on a shelf. They must be manufactured from raw stock. The technician utilizes a massive metal lathe to cut a precise steel cylinder. The workpiece spins at high speed, while a hardened carbide cutting tool is slowly driven across its surface. The sharp tool shears away continuous ribbons of metal, reducing the diameter of the stock with incredible precision. The lathe bed catches the hot steel shavings as the part takes shape. This machining process requires a deep understanding of metal properties and cutting speeds to achieve a perfectly smooth, dimensionally accurate finish. A few thousandths of an inch too deep, and the part is ruined. By fine-tuning the cutting depth, the technician crafts a custom hydraulic component that will fit the restored excavator perfectly. It is a slow, methodical process that relies entirely on the operator's skill to turn a rough billet of steel into a vital mechanical connection. This capability to fabricate, rather than just replace, is the true mark of a complete heavy machinery restoration. The heavy rotary mechanisms of the undercarriage are prepared for installation. The technician uses a cordless drill to rapidly run down the mounting bolts on a large, heavy gear assembly, because this exposed gear will operate in highly abrasive environments. Standard thin oil is useless. He thickly coats the heavy metal teeth with a layer of clear, high-tack grease. This dense lubricant sticks to the metal under extreme pressure, preventing the steel gears from grinding each other into dust as the heavy cab rotates. He drops the final bolts into place by hand, aligning the heavy black casting on the shop floor. The sheer weight of this assembly requires a careful, deliberate approach. This central gear system will bear the entire rotational full force of the excavator's upper body. Its smooth operation relies entirely on the thick barrier of fresh grease applied during this crucial assembly step. Without this heavy lubrication, the friction would generate immense heat, quickly destroying the newly restored metal surfaces. Fluid storage is vital for a machine driven by oil pressure. The massive black hydraulic reservoir is hoisted onto the freshly painted green frame. This tank holds the dozens of gallons of specialized fluid required to operate the cylinders. The mechanic uses a socket wrench to bolt the heavy steel tank securely to the chassis, ensuring it can withstand the violent vibrations of the diesel engine. Once anchored, the plumbing begins. He threads small metal return fittings into the tank's sidewall before pushing a thick, low-pressure rubber return hose onto the main pipe. A simple metal hose clamp is tightened with a screwdriver, locking the rubber in place. This reservoir acts as both a storage tank and a heat sink, allowing hot hydraulic fluid returning from the boom to cool and settle before being pulled back into the high-pressure pump. the massive structural components of the lifting arm finally begin to come together. The technician aligns a heavy circular metal plate onto the yellow-painted base of the boom. This plate acts as a thrust washer, a sacrificial wear surface that absorbs the lateral friction between the heavy-moving arm and the stationary frame. Next, the primary hydraulic lift cylinder is wrestled into position. Guiding this heavy green cylinder requires both hands and precise balance, aligning its steel mounting eye perfectly with the yellow bracket on the chassis. The black and green frame now sits solidly on the concrete, ready to bear the weight of the digging implement. He slides a small securing pin into the bracket linkage, manually aligning the internal bore. A heavy metal hammer is used to drive the pin fully home. Striking steel on steel, he forces the tight tolerance pin through the mounting bracket, permanently anchoring the base of the lifting cylinder. This single pivot point will soon transfer thousands of pounds of lifting force from the hydraulic ram directly into the heavy boom arm above. The precise fit of these pins is what prevents dangerous structural slop when the machine is operating at its maximum reach. The largest single component of the excavator, the massive green boom arm, is finally brought to the chassis. Suspended perfectly over the yellow mounting bracket, the heavy steel structure hovers exactly in alignment with the mounting boards. The technician slides the main pivot pin into the massive hinge. This thick steel cylinder is the critical load-bearing joint for the entire machine, carrying the weight of the arm, the bucket, and whatever earth it scoops. An impact driver secures a locking bolt on the end of the pin, preventing it from walking out under heavy vibration. The secondary hydraulic cylinder is then positioned, and a steel washer is tapped onto the pin to distribute the lateral load. Heavy hammer blows drive the final retaining pins through the upper cylinder mounts. The violent sound of the hammer securing the pins echoes through the shop, signaling the successful mating of the boom to the chassis. The hydraulic muscles and the steel bones of the machine are now permanently connected, transforming the static frame into a capable lifting machine. Every joint must be perfectly aligned before the hammer strikes. Binding a pin halfway through its bore requires hours of difficult extraction to correct. At the very end of the boom, the business end of the excavator is attached. Kneeling on the harsh concrete, the technician maneuvers the heavy black digging bucket into alignment with the bright green hydraulic arm. He inspects the thick steel hinge pin, checking for any burrs or imperfections that could cause it to bind in the tight bore. With a heavy metal hammer, he drives the pin through the cast iron hinge. A second worker helps stabilize the awkward, heavy mass of the bucket, while the massive pin is forced home. He aligns the secondary linkage point, guiding the thick, metal dog bone connector into the bucket's upper bracket. These two hinge points allow the bucket to curl and dump with immense breakout force. The contrast between the fresh green paint of the boom and the heavy black iron of the bucket highlights the raw utility of the attachment. The machine is finally armed and ready to dig. These pins will endure the most brutal wear of any component, submerged in dirt and rock every time the machine works. Power delivery to the ground requires heavy-duty gearing. A green power impact wrench rapidly spins the mounting bolts into the black undercarriage, preparing the final drive hub. The technician lifts the bright yellow drive sprocket, sliding it onto the heavy spline shaft. This large, toothed wheel is the only component that actually pulls the heavy rubber track, converting the hydraulic motor's rotation into forward momentum. He secures the heavy steel bolts, locking the yellow sprocket against the black frame. The sharp contrast in colors makes it easy to spot any loose bolts during daily maintenance checks. The sheer torque applied by the impact wrench ensures the sprocket can withstand the violent shock loads of climbing over rough terrain without shearing its mounting hardware. Installing the continuous rubber tracks is one of the most physically demanding steps of the reassembly. The heavy, reinforced rubber belt is incredibly stiff, fighting every attempt to bend it around the undercarriage. The technician uses a long metal pry bar to lever the massive weight of the track over the drive sprocket and front rollers. Kneeling on the concrete, he manually guides the thick rubber links, ensuring the internal drive lugs seat perfectly between the steel teeth of the yellow sprocket. It requires the coordinated effort of two workers to stretch and align the heavy belt around the long frame. The thick rubber must be perfectly centered on the bottom rollers. If it is misaligned, the track will immediately derail the moment the machine attempts to turn. Once the heavy loop is fully wrapped over the front and rear wheels, the track rests loosely on the frame, ready for the immense pressure of the final tensioning mechanism. a loose track will slip off its guides on the first tight turn. To take up the slack, the technician slides the heavy front idler wheel assembly into its slotted channel in the black frame. Once the rubber lugs are correctly engaged with the sprocket, he attaches a high-pressure grease gun to a small internal valve. Pumping thick grease into the sealed tensioning cylinder slowly forces a heavy internal piston outward. This hydraulic pressure physically pushes the front idler wheel forward, stretching the massive rubber track taut against the frame. He carefully monitors the tension as he pumps, ensuring the track is tight enough to prevent derailment, but with enough slack to absorb the impact of rocks and debris. This ingenious grease-filled tensioner acts as a heavy shock absorber for the entire undercarriage. The mechanical puzzle is finally complete. The technician climbs into the operator's seat to awaken the machine. The diesel engine fires, instantly pressurizing the complex hydraulic network. He cycles the control joysticks, feeling for any hesitation in the valves. The heavy boom rises smoothly, and the cab rotates on the freshly greased swing, bearing without a shudder. The tracks engage, biting into the concrete with fresh rubber. After weeks of silent, static teardown, the violent noise and fluid motion of a working machine flood the shop. The excavator responds flawlessly to every command, its hydraulic muscles fully restored. Final touches are purely aesthetic, but they signify the completion of the long journey. The technician carefully applies the iconic yellow Komatsu decals to the bright green boom. Peeling back the transfer paper reveals the crisp vinyl lettering, instantly giving the restored machine its identity back. He smooths the letters down, sealing them against the fresh paint. A high-pressure water wand blasts away the accumulated shop dust and oily fingerprints from the reassembly process. The water cascades off the vibrant paint, revealing a machine that looks as though it just rolled off the factory floor, a stark contrast to the mud-caked relic that was dragged in weeks ago. The branding is a badge of honor, marking the end of a successful, exhaustive overhaul. The excavator rolls out of the workshop under its own power, a triumphant exit for a machine that arrived as a dead weight on a crane. It tracks smoothly toward the street, climbing the steep steel ramps of the flatbed transport truck without hesitation. The repaired diesel engine easily powers the heavy tracks up the incline. What was once a rusted, seized scrap pile is a working machine again, revived, fully operational, and ready for heavy labor. Every hidden bearing they replaced, every hydraulic seal they crimped, is what its reliability now rests on. A machine this well built is never truly dead. With the right hands, patience, and fire, It simply waits to be rebuilt. Some things are undeniably worth the long road back. It leaves the shop not as a relic, but as a capable, powerful tool once again.